Hi, my name is Basir. This is the third video in our playlist in which I'm teaching you Chapter 10 Mensuration from Telangana State Syllabus. In this video, we mostly need to find out the surface area of combination of solids. From the on the screen, you see a ice cream, right? Ice cream here consists of two shapes here. Now, this shape that you see here, the red color shape or the brown color shape, that is the cone. That's the shape of a cone, and this thing here, the yellow ice cream that you see, that is in the shape of a hemisphere. So you have if we consider the example of this ice cream, we have two shapes. One is a cone and the other is a hemisphere. Likewise, if we see a tank here, um, we see that it's a combination of, again, uh, three shapes here, two shapes here actually. um, One is a cylinder here, and then at both the ends of the cylinder you have two hemispheres attached to the cylinder, right? So we have to find out surface area of combination of solids in exercise 10.2, and it's not that difficult. Let's say I have to find out let's say I have to find out the surface area of this shape. Then I just need to find out curved surface area of cone, and then I just need to find out curved surface area of hemisphere. Add them together, I'll get the total area of total surface area of this object. So it's not at all that difficult. You have a set of 9 questions, I believe, in this exercise. I will omit one or two questions here and there, but then I'll give you a hint. I'll give you a hint how to go about solving that question, just so you have a little practice of doing of solving problems on your own. Now, the first question in exercise 10.2 says a toy is in the form of a cone mounted on a hemisphere. So I'm drawing a hemisphere here. That's my hemisphere. That's my hemisphere. Okay. So on this hemisphere we have a cone. Let's say this is our, oh my goodness, let's say this is our cone here on the hemisphere. The diameter of the base and the height of the cone are 6 centimeter and 4 centimeter respectively. The diameter of the base, the complete diameter here, this complete diameter is given as how much? 6 centimeter. If the diameter is 6 centimeter, we know that the radius will be half of it, so the radius would be 3 centimeter, and the height is given as 4 centimeter. Okay, so this height here is 4 and this radius here is 3. That's what it says, right? A toy is in the form of a cone mounted on a hemisphere. The diameter of the base and the height are 6 and 4. So the diameter is 6, height is 4. Determine the surface area of the toy. Now, to find out the surface area of this toy, which has two shapes, one, the cone, which is mounted on the another shape, which is a hemisphere. First, we'll find out the curved surface area of cone. Curved surface area of cone is nothing but pi r L. We don't know the value of L, so we'll first find out the value of L. You just have to use Pythagoras theorem here, or you can just make use of this formula here. L square is equal to r square plus h square. R is 3, h is 4, 3 square is 9, 4 square is 16, so L square will be 25, L will be square root of 25, which is 5. So the slant height here is 5 centimeter. Now let me substitute it here. In the question it's given, they are asking us to use the value of pi as 3.14. So I'm substituting the value of pi as 3.14. If it's not mentioned in the question, then we can use the value the value of pi as 22/7. If it specifically says that you have to use the value of pi as 3.14, then we'll have to use the value of pi as 3.14. So r here is 3 and the value of L is 5. let me multiply this. 3.14 into 3 into 5 is 15. 5 into 4 is 20. 5 ones are 5, 6, 7. 5 into 3 is 15. 4, 1, 3. 7 plus 4 is 11. 5, 6, 7. 3 plus 1 is 4. So I'm getting 47.10 centimeter square as the curved surface area of cone. Now the other shape that you see here, it's the hemisphere. Let us find out curved surface area of hemisphere. Curved surface area of hemisphere is 2 pi r square. 2 into the value of pi is 3.14 into the value of r is 3. So 2 into 3.14 into 3 square is 9. 2 into 9 is 18. So I'll have to multiply 3.14 by 18. 8 into 4 is 32. 8 ones are 8. 8 plus 3 is 11. 8 3s are 24. 24 plus 1. 24 plus 1 is 25. 4, 1, 3. 2, 5, 6, 5. So I'm getting 56.52 centimeter square as the curved surface area of hemisphere. Now we have to find out the total surface area of this object. To find out the total surface area of the object, total surface area of this toy is nothing but CSA of cone plus CSA of hemisphere, right? Because you have two shapes here. One is a cone here, this one here, this one here is a cone, and this is a hemisphere. So we found out the CSA of the cone and we also found out the CSA of the hemisphere. CSA of cone, we got it as 47.10 plus CSA of hemisphere is 56.52. 47.10 plus 56.52, that should be equal to 103.62. I see that in the textbook it says the answer is 103.71 centimeter square, but we are getting 103.62. Don't get confused. I actually verified this. I see that when we substitute the value of pi as 22 by 7 instead of substituting the value of pi as 3.14, we are getting the textbook answer, which is 103.71. But I have used the value of pi as 3.14 because it specifically mentioned it specifically asked us to use the value of pi as 3.14 in the question itself. Okay, well, I'll move on to the second question in our list here. A solid is in the form of a right circular cylinder with a hemisphere at one end and a cone at the other end. So we have a cylinder here. So that's our cylinder. That is our cylinder. And to one end of the cylinder, we have a hemisphere connected to it. Let's say this is the hemisphere. And then the other end of the cone, you have a this thing connected. So this side here is a hemisphere, and then this side you have a cone. The radius is given and the height of the cone and the height of the cylinder is given. The height of the cylinder is given as 10. The height of the cone is given as 6. The radius is given as 8. Radius is given as 8. We are asked to find out the total surface area of the solid. And again, it's asking us to use the value of pi as 3.14. This I'm not going to do. This I'll just give you a hint. I'm sure you can do it on your own. This is very similar to the first one. In the first one, we just had one cone mounted on a hemisphere, but here we have a cylinder and we have two shapes connected to each of its ends. One is a hemisphere and the other is a cone. You just have to find out the curved surface area of hemisphere. Find out the curved surface area of hemisphere. Curved surface area of hemisphere is given by the formula 2 pi r square. You have the value of r as 8. Substitute the value of r, you will get the curved surface area of hemisphere. Next, you have to find out the curved surface area of cylinder, which is given by the formula 2 pi r h. You know the value of r is 8. You know the value of h is 10. Value of pi is given as 3.14. Substitute it and get the value of curved surface area of cylinder. After this, find out the curved surface area of cone. Curved surface area of cone is pi r l. You don't know the value of l, so use this relationship. L square is equal to r square plus h square to find out the value of l. Once you have it, you can find out the curved surface area of the cone. To find out the total surface area of this shape, you just have to add all of these three. Add all of those three: the hemisphere, the cylinder, the hemisphere, the cylinder, and the cone. Add all of these three and you'll get the total surface area of the complete solid. Third question, I'll do it because this third question is a little bit tricky here. So this one I'm going to do it. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. So we have a capsule which is in the shape of a cylinder with two hemispheres connected to both of its ends. The length of the capsule is 14 millimeter. Here, the length of the capsule here is 14 millimeter. This complete length is 14 millimeter and the width is 5 millimeter. The width is 5 millimeter. This width completely, this width is 5 millimeter. The width is 5 millimeter, which means which is nothing but the diameter. This width is nothing but the diameter, right? So the diameter of the cylinder or the sphere is given as 5. The radius will obviously be 5 by 2, which is 2.5, right? Now there's a catch here. The height of the cylinder is not given here. It gave us the length of the capsule. The capsule consists of a cylinder and then it has two hemispheres at both of its ends, and the total length is 14 millimeter. So this 14 millimeter that you see here is not the height of the cylinder. It's not the height of the cylinder. It is the total length of the capsule. So what we have to do is, here we have a hemisphere and the radius of the hemisphere, we know that it is 2.5. So I'll have to subtract 2.5 from here, and then the radius here again is 2.5. So I'll have to, if I remove this 2.5 plus 2.5, if I remove 5, 2.5 plus 2.5 is 5, right? So if I remove 5 millimeter from this 14 millimeter, I get 9 millimeter, which is the height of the cylindrical part. I'm excluding the radius of the hemisphere here. I'm excluding the radius of the hemisphere to find out the height of the cylinder. So the height of the cylindrical part is 9 millimeter. That's the catch here. Now let us find out the curved surface area of cylinder. Curved surface area of cylinder is 2 pi r h. 2, I believe they wanted us to use the value of pi. No, the value of pi, we can use it as 22 by 7 because it's not mentioned that you have to use the value of pi as 3.114. If it's not mentioned, we are good to use the value of pi as 22 by 7. R is 2.5 and h is 9. The height of the cylindrical part is 9, right? What do I get? 2 into 2.5 is 10. 9, 22 into 9 is how much? 22 into 9 is 9 into 2 is 18. 9 into 2 is 18. 18 plus 1, 19. So I get 1980 by 7. 2 into 2.5 is No, no, I won't get this. 2 into 2.5 is 5. So this actually should be 22 into 9 into 5. So I'll have to multiply this with 5. 22 by 7 into 2 into 2.5. 2 into 2.5 is 5 here. So 9 into 25, 22 into 5, I'll just do it like this. 22 into 5 is 110. 110 into 9 is 990. So this will be 990 by 7 millimeter square. That's the CSA of the cylinder. Now we'll find out the CSA of the hemisphere. CSA of hemisphere. CSA of hemisphere. What's the formula for finding CSA of a hemisphere? It is 2 pi r square. 2 into the value of pi is 22 by 7. The value of r is 2.5. 2 into 22 is 44. 44 by 7 into 2.5 square would be 6.25. Right. 6.25 into 44 should be 4 into 5 is 20. 4 to the 8, 9, 10. 4 6 are 24. 1 25. 0 0 5 2 5 7 2. So it should be 275 by 7. by 7. Now to find out, this is just the curved surface area of one hemisphere, but we have two hemispheres attached to the cylinder, right? Attached to the cylindrical part. So we'll find out curved surface area of two hemispheres, which should be 275 by 7 into 2. 275 into 2 is how much? 2 5s are 10, 2 7s are 14, 1 15. 2 into 2 is 4, 4 plus 1 is 5. 550 by 7. Now if I add 990 by 7 and 550 by 7, I'll obviously get the total surface area of this capsule. I wanted to complete this problem, but the sheet is complete. I'm sure you can just add these two fractions to find out the answer. So add these two fractions, 550 by 7 and 990 by 7, and let me know what is the answer for question number 3. I'll move on to question number 4 here. Question number 4 says, two cubes each of volume 64 centimeter cube are joined end to end together. Find the surface area of the resulting cuboid. Now, there are two cubes each of volume 64 centimeter cube, right? So let's say this is my cube, which has a volume of 64 centimeter cube, and then there's another cube which is attached to this, and the volume of that cube is also 64 centimeter cube. Now when I attach two cubes to one another, it actually becomes a cuboid. The larger figure that we get is that of a cuboid, and we have to find out the surface area of the resulting cuboid. Finding out the surface area of a resulting cuboid, this is pretty simple. Now, volume of cube, oh my goodness, let me write this once again. This writing is pretty messy. Volume of cube is 64 centimeter cube. Now volume of cube formula is a cube. A cube is 64. 64 I can write it as 4 cube, right? 4 into 4 is 16. 16 into 4 is 64. Now when the powers are equal, so I can equate the bases. The value of a would be 4. So this side here is 4, and obviously this side will also be 4 because this cube also has the same volume 64, so the side will be 4. Now this cuboid that we get here, the complete cuboid that we get here, this cuboid will have the length as 4 plus 4, which is 8. The length of this cuboid will be 8. The breadth will still be the side of the cube, which is 4, and the height will also be 4. Breadth will be 4 and the height will also be 4, but the length of the resulting cuboid is 4 plus 4, which is 8. Now we have to find out the total surface area of this cuboid. Total surface area of cuboid is nothing but 2 into LB plus BH plus LH. L is 8, B is 4, B is 4, H is 4, L is 8, H is 4. So I get 8 into 4 is 32, 4 into 4 is 16, 8 into 4 is 32. 32 plus 32 is 64, 64 plus 16 should be 80, right? 64 plus 16 should be 80. So 2 into 80, that is 160 centimeter square. That's the total surface area of this resulting cuboid. Let me work out problem number 5 now. Problem number 5. A storage tank consists of a circular cylinder with a hemisphere attached on either end. Same like the third one. In the third one you had a cylindrical part, and then you have two hemispheres attached to both of its ends, right? In the same way, the fifth question also says that there's a circular cylinder, and then you have hemispheres stuck on either end. The diameter is given as 1.4 and the length is nothing but the height of the cylinder is given as 8 meter. You have to find out the cost of painting it on the outside at the rate of 20 per meter square. This I am going to leave because this is pretty simple. This is straightforward. The height of the cylindrical part is already given in the previous question number 3. Finding out the height of the cylindrical part was a bit tricky because the height of the cylindrical part was not directly given. Instead, the length of the capsule was given. So we subtracted the radius of both of the hemispheres and we found out the height of the cylindrical part. But in this question number 5, the height of the cylinder is given directly here. You have the diameter, which is 1.4. From the diameter you can find out the radius, which should be 1.4 by 2, so it should be 0.7 meter. And you just have to find out the CSA of both the hemispheres, find out the CSA of the cylinder, add them up. Whatever surface area you get, multiply that with 20. You will get the cost of painting the complete storage tank. So this you can do it on your own. I just gave you a hint. Sixth one, I'll do the sixth one, not the fifth one. So I'll make the sixth. A sphere, a cylinder and a cone have the same radius and same height. Find the ratio of their volumes. So I have to find out the ratio of volume of sphere is to volume of cylinder is to what's our next figure? Cone. Volume of cone. So we have to find out the ratio of volume of sphere, cylinder and the cone. It's given that the radius and the height are same. We have to find out the ratio of their volumes. Now we know that the volume of a sphere is given by the formula 4 by 3 pi r cube, and the volume of cylinder is pi r square h, and the volume of cone is 1 by 3 pi r square h, right? Now if you look very carefully, you have in the sphere you have only one variable r, but here in a cylinder and in a cone you have two variables, r and h. So what I'll do is I will do this. We have a hint given here in the question. Diameter of the sphere is equal to height of the cylinder and the cone. So the diameter of the sphere, diameter will be 2r, right? So this 2r is equal to height. That is given as a hint in the question. The diameter of the sphere, diameter is nothing but twice of radius, right? So diameter 2r, that is equal to h. That's the hint given in the question. So what I'll do is I will do this. This 4 can be written as 2 into 2 pi cube. I can write it as this r cube that I can write it as r square into r. I'll show you why I've written it that way. I wanted to make this 2r, in place of this 2r I wanted to substitute h. That's the reason I have written it in this way. So what's remaining here? 2 by 3 is remaining, pi r square is remaining, and this 2r, in place of 2r I can write h, right? Because it is given the diameter of the sphere is equal to height of the cone and the cylinder, which, so 2r, in place of 2r I am writing h. Now this pi r square h, gets cancelled, and this pi r square h gets cancelled. What do I get here? 2 by 3 is to 1 is to 1 by 3. And what are the denominators here? 3 and 3. The LCM of 3 and the LCM of 3 and 3 would be 3. So I have to multiply all the terms by 3. I'm multiplying the first term by 3, I'm multiplying the second term by 3, and I'm multiplying the third term by 3. So here I get the ratio of the volume as 2 is to 1 is to 3. In the answer, I see that it's given a different answer. When I cross-checked it, I see that in the question they have asked us to find out the ratio of volumes, but the answer that's given that's given in the textbook belongs to the ratio of their CSA, the ratio of their curved surface area, and not the ratio of their volumes. So I'll find out the ratio of their curved surface areas also. Let me find out the ratio of their curved surface areas. Okay, I'll have to take a new worksheet here. I'll pause the video, take a new worksheet, and come back. So now I'm going to find out the ratio of curved surface area of sphere, the cylinder, and the cone. Curved surface area of sphere is nothing but 4 pi r square, and curved surface area of cylinder is 2 pi r h, right? And then the curved surface area of cone is pi r l. Curved surface area of cone is pi r l. Now I'll do this thing. What I will do is I'll write this 4 pi r square as it is. In place of, I'll write this 2 pi r as it is. In place of h, I'll write 2r, because in the question it is clearly given here that the height of a cylinder is equal to diameter of a sphere. Diameter of a sphere is 2r, right? So in place of h, I'm going to write 2r. So in place of this h, I'm going to write 2r. Pi r l. L square, we all know that L square is r square plus h square, right? L square is r square plus h square. Now we know that h is 2r, right? Here h value is 2r. So in place of h, I am writing 2r. L square would be r square plus 2 square is 4r square. So L square will be 4r square plus r square would be 5r square. L will be, if I remove square on the left hand side, I'll have to put a square root on the right hand side, right? This root, it goes for 5 also, and then if it goes for r square, square and square root gets cancelled, I get r. So the value of L is square root of 5r. Let me break this thing for you. Root, I'll take it for 5 also, root I'll take it for r square also, right? I believe everybody knows this. Square root of AB is root A into root B. So I'm writing it like this. Square root of 5r square is root 5 into root r square. This root 5 remains as it is. This square and square root gets cancelled. I get r. So the value of r is root 5r. So the value of L here is root 5r. Now let me write this thing down. 2 into 2 is 4. 2 into 2 is 4. Pi r square is to root 5 pi r square. That's what I get here. This pi r square, this pi r square, this pi r square gets cancelled, and the ratio that I get is 4 is to 4 is to root 5. So that's the ratio of curved surface area of sphere, cylinder and the cone. Let me do the next question here. The next question says, a hemisphere is cut out from one face of a cubical wooden block such that the diameter of the hemisphere is equal to the length of the cube. Determine the surface area of the remaining solid. Okay, I'll do the 7th one, and the 8th one you can do it on your. So the seventh question says, a hemisphere is cut out from one face of a cubical wooden block. Let's say this is our cubical wooden block. We are cutting out a hemisphere at one of its ends. So this is the hemisphere that I cut out. The diameter of the hemisphere is equal to the length of the cube. Let us say the length of the cube. Let the length of the cube is x units. Let us say that the length of the cube is x units. Then the diameter of this hemisphere, the diameter of the hemisphere will be x, because it is it clearly is visible, and it is also mentioned in the question that the diameter of the hemisphere is equal to length of the cube, length of the side of the cube. Length of the side of the cube is x units, so the diameter would be x. Now if the diameter is x, the radius would be x by 2. The radius will be x by 2. We have to find out the surface area of the remaining solid. If we want to find out the surface area from the remaining solid, we actually need to do this. We first have to find out total surface area of cube, and then we have to add CSA of hemisphere, curved surface area of hemisphere. From this, we have to subtract this side, because when, let's see, I draw the figure once again. This is our cube. Now we are cutting out a hemisphere here. If we cut out the hemisphere, this side of the cube, it goes away, right? This side of the cube, it goes away, and this side of the cube will actually form the the base of the hemisphere, which is a circle. So I'll have to remove the area of a circle from here. I'll have to add total surface area of cube, and I'll have to add curved surface area of a hemisphere. Then I'll have to subtract this thing. So I'll have to subtract the area of a circle, because the length of the top, the side of the top cube is missing here once we cut out a hemisphere. So this is what we really need to do. Okay, let's see here. Total surface area of cube, it is 6a square, right? The formula for finding the total surface area of cube is 6a square. A is nothing but the side of the cube. The side of the cube, we denoted it by x, so it will become 6x square, right? 6x square. In place of a, I'm writing x, because we assume that the length of the cube is x. Now CSA of hemisphere, curved surface area of hemisphere. Curved surface area of hemisphere is given by the formula 2 pi r square, right? And then this pi r square I'm writing as it is. So this becomes 6x square plus 2 pi r square minus pi r square would be pi r square. 2 pi r minus pi r square is pi r square. In place of r, I'm going to substitute x by 2 because the value of r is x by 2. 6x square plus pi x square by 2 square is how much? 4. So this becomes 6x square plus x square by 4 pi. If I take x square common from this, I'll get 6 plus pi by 4. X square into 6 plus pi by 4 is the area of the remaining solid. Eighth one, I'm sure you guys can try it on your own because it's just a similar case. You have a cylinder here, and then you have two they have scooped out two hemispheres from both the ends of the cylinder. I'm sure you can try it on your own. Try it and let me know the answer. If you don't get it, let me know.